That's exactly what I just support. I still get I think that's all. Did I say or should I have?
Okay. It's really
We're on. I think we're on the.
Okay, so before we get started, trying to actually log on to Slido. Okay, so then part control for you to do it now to make sure they can actually go to the Slido and do this response. And if you have any questions, okay, now is a good time to start to post your questions. Okay.
She's so much. Left the red part. Looked over his watch. 6 o'clock. Some food shopping.
Yeah.
Computer science. CIS. Minus like just. Cheers, dude.
I mean, that's valid. I don't think the answer. Oh, you guys do like a oh, no.
Which question? So it's right.
Okay, let's get started. Okay, so on the board you can see there are these are questions, right? So how can we get A if you want to actually really do well for this class? And you see this multiple choice, right? So these 4 bullet points is actually collected from the student I told before. We actually got A, and I asked them to share their tips to the future students. These are the 4. Okay, so they did all 4 to ensure they can get an A. Okay, and I guess the first one actually bring you the background knowledge that you have to allow you to actually do and comprehend the questions, right? So make sure you actually go through those YouTube videos step by step. Okay, so we have this weekly base curriculum. Okay, make sure you actually go through those videos before actually walk into here. Okay, I also want to emphasize that this is actually a flipped class. Okay, doesn't mean it's actually a better mechanism for everybody. Okay, you are your own boss. You choose the method that works the best for you. Okay, this is a method I enjoy the most, so I will continue doing this approach for my lecture at the UH. Okay, so if you found these things doesn't work for you, it is actually a good time to switch to other sections. Okay, it doesn't really matter whether you want to actually stay here or not. Okay, it doesn't really matter. What matters is actually, do you get the things that you are paying for, right? So we all know that taking a courses in the university is actually quite expensive. How much money you have to pay per credit? 1,000 for a class, right? How many hours do you actually have for a class like this? 3 hours per week, right? And we have 14 weeks. That's 52 hours, right? So 1 hour is actually $20. It's actually quite expensive, right? And in contrast, okay, if you go to the movie theater, you watch a movie, you spend $20. You're so focused, right? And then at least you get some fun. Okay, so let's actually, okay, why are you paying $20 for that, right? And you're doing the same, you're paying the same thing, right? And you want to actually make sure you actually get things that you want, right? You need to actually think about, okay, what are the things that matters to you if you take these courses? That's the things I want you to actually think about. That's the things that matters. Okay. Let's actually know one fits all policy here. Okay. Every professor is going to teach in their own styles. It may work for you, it may not. But you are the one who need to make decisions. If it doesn't work for you, okay, it is good to just switch the sections. Find someone that can help you to achieve the goal you want to achieve. Okay. So that's actually things I want to say. Since this is just the beginning of the semester, if you decide to switch earlier. Okay. And these are the 4 tips. Okay, not coming from me, it's coming from students. Okay. So the first one, provide a knowledge base for you to actually know why you actually solve the problem in a specific way, right? The second is actually identify keywords. These are the things we practice all the time. In the in-person lecture, that's actually the only thing we do, right? We actually, I tell you how to read the questions, how to identify the keyword, how to associate your keyword to the key concept and key equation, and you solve for it, right? So that is actually the only way you can actually speed up. So that's actually something we need to actually keep practicing, okay? And then the third point is actually really encourage all the students to actually participate in this in-person lecture, because if you have questions, the best way is actually you ask me, right? Because I'm the one who teach all this content. I'm the one who needs to be responsible for what I teach, right? Yeah, so if you go to the tutors, yes, they can say something. They have their own theory. They have their own way to solve their problem. But that's theirs, not mine, right? So I cannot be responsible for what I told you. Okay, so I would strongly encourage you that you actually participate in the in-person lecture and really ask the question proactively. That's actually the best way to save your time to get the grade that you want. The ultimate goal is actually the number 4, right? You can really solve the problem really quickly. That's actually the only way you can get good score, because under all this midterm and final, you have so many questions. You have a limited amount of time, right? You're under high pressure. Okay, you need to be solve all those questions within a given amount of time. Therefore, you need to be really good at identify keyword associated with the key concept, know what equation to use, and do the calculation quickly. Okay, so if you can do all these 4, then I guess you will actually get A for these lectures. All right. So let's actually a quick summary of these 4 points. Okay, any other questions? Okay, so if not, let's see. No Q&A. Oh, come on. Yes, I have a great pickup. Yeah, so my wife cut it for me for sure. Okay, she has been cutting my hair for, I don't know, 15 years. Yeah, so I think it's good. Yeah, and that's the only thing I care about. All right, so I don't think there's actually too many questions. I assume everybody's actually fine with the contents, okay? Yeah, so. Okay, I want to actually address the second one now. How should we approach the weekly video? Do you know we have a team site? If you do know we have a team site, I think I post all the video link on the team site. Okay, so in the general channel, okay, so just make sure that you know what I'm talking about. So we use Microsoft Teams. Okay, I've been using Teams for many, many years now. Okay, so this is actually our team site. Okay, so if you go to the team site, you can see this YouTube lecture video for the midterm one is actually all posted here. You can click here to get to the content, okay? And then these are the associate hangouts you will be using for those YouTube videos, okay? So now it's already week 3, okay? This is actually beginning of week 3, right? So if you want to catch up quickly, okay? Because if you're falling behind, like I say in the very first lectures, okay? The course is actually designed in a very unique way, okay? Every week you have new content, okay? And you need to know the first content so you can actually, so that the subsequent content will actually make sense to you. Okay, so if you're actually falling behind, you need to actually always jump all the way back to the first lecture and go all the way to the things that we actually at right now. Okay, so the later you begin, you will suffer the most, right? So you want to actually just follow up. If you just follow up the schedule, it's actually relatively easy because every week we only actually input a little bit, right? And then if you can really understand how to solve problems, you'll feel okay, all the things actually connect actually very logically. Okay, so by doing that, you actually lower down time you need to actually solve all those problems. Okay, they will actually naturally actually reflect on the grade you're going to have for your homework and the quiz. All right. So if you haven't get started now. Okay, so you still have some good chance to actually catch back to the level that you want to be. Okay, there's actually a very unique rule for this for CHEM 1312. Okay, which is actually stated in the syllabus. Is that I think if you fail more than 4 homework or 4 quizzes, you'll be blocked out of Canvas, right? Therefore, you can actually do the homework or quizzes in the future. They will actually force you to actually drop off this class, right? Does anyone know this rule? Okay, so that is actually so because we lost 1 lectures, right? So I didn't actually go through the syllabus as detailed as I want, like usual. Okay, but for 1312, okay, no matter which section you are at, okay, if you miss or fail more than 4 quizzes in a row, then you will be blocked out of the Canvas, I think, or the Cengage, meaning you can actually do future homework or future quiz. Okay, and since you cannot do that, then pretty much block out you from actually doing the exams as well. Therefore, you're going to get an F if you don't actually drop the course, right? So in order to actually prevent those things from happening, the best way is actually really just do things as planned. Okay, so that's actually something I think is I probably should actually emphasize a lot more earlier so that maybe you guys get a better sense. Okay, so really follow the syllabus and then follow the schedules. I think that's actually the best way to get the best grade you can actually expect to have. Okay, and yes, stay up to date is essential. Okay, this is actually something that this is actually the best way I would recommend to do it. Okay, otherwise you're going to spend a lot more effort to reach the level that you want to be. Okay, but again, you are your own boss, right? My role is here to help, but I can only help those people who want to help themselves, right? So I respect all of you. Okay, really, I respect your time. Okay, your decision is your decision. Okay, all I can do is actually just telling you, okay, what will be actually a more smart way or reasonable way, okay, to plan your own future. All right. Another thing I want to mention here is that we have office hour on Friday morning, 9 to 11. Okay. My office is in Fleming 139E. Okay. Does everyone know how to get to that room? Okay. It is actually inside an office complex. And to actually enter from door 137, then you actually see my office inside. Okay, so if you want to ask any questions, just walk in during the period of time. Okay, but if last schedule doesn't work for you, okay, just email me the time that works for you. I will tell you whether I can meet at that time or not. If I can meet, we will meet at that specific time. Okay, so use the resource wisely. Okay, so what are the resources? I am a very useful resource for these specific courses. Okay, so if any questions, okay, just email me. Okay, and then I also noticed that many of you send a message through Canvas. Okay, and those things will actually eventually become email that go to my email address. then I probably actually respond to my email address through there. Okay. It's somewhat complicated. Okay. The easiest way to actually reach out to me is just a message through Teams. Okay. If you just message through Teams, very likely I will actually respond in real time if I can respond. Okay, so I would strongly suggest that you reach out to me using Microsoft Teams message. Okay, that's actually the easiest way that I can just see and respond as fast as I can. All right. Okay, so I think that's actually all the things that I want to talk before we actually enter in chapter 11. All right, so chapter 11. This is the hangout that you have. Okay, we actually only have 4 types of questions that you want to actually get really familiar with. Okay, so hopefully today we can finish the first 3, and then on Thursday we can finish the 4th one. Okay. So last week we actually talked about the reaction rate, right? So we started by finding the term of rate, and what we say is actually we want to actually know how much change that happening for a specific quantity over a period of time, right? So your numerator will always be concentration term in this case, right? For this specific chapter, we want to have to know how the concentration is changing over a period of time, right? For a given chemical reaction, here we give you this example, right? AA plus BB, like give you CC plus BB, where we call capital A and capital B as reactant. Very good. Okay, it's very important concept. Okay, you need to know A and B is the reactant, and C and D. Very good. And this lowercase a, b, c, d is called coefficient. Okay, be more professional. You want to say it's actually a stoichiometry coefficient. Okay. And then the way we define the overall rate, okay, the overall reaction rate, okay, will be the change of either defined by your reactant or defined by your product. Okay, over a period of time, normalized by its coefficient. Okay. Another very important thing here is that the rate is always positive. Okay. When you calculate the change of the concentration for your reactant, you know, as time goes by, your reactant is going to decrease, right? Therefore, when you calculate the delta A, it will be actually a negative number. So in order to convert that negative number to make it become a positive, so it can be representing the rate. Okay, that's why you actually put a negative sign in front of your reactant. Right, that's why you have this. For your reactant, you always have a negative sign in the front. Your product is actually opposite, right? Because products are actually going from none to a lot, right? So if you do this final concentration minus the initial concentration, for your product side, your rate is always positive. Therefore, you don't put a negative sign in the front. All right? And then you should also have a clear idea that here we say the overall reaction rate. Okay, so let me just write this. Reaction rate is defined as this is actually the overall reaction rate. If I want to know just the consumption rate of your reactant, that is actually this quantity. Okay, so if it's actually asking the consumption rate of A, it's asking to calculate delta A over delta T, right? Of course, you know this is actually negative, so you want to put a negative sign in the front so that the rate becomes positive. Okay. But if I'm asking the overall reaction rate, it will be delta A over delta T, take the negative sign, and also normalized by the coefficient. Okay, so let's actually main difference between the two. You need to actually make it very clear. Okay, because when you got asked in your question, you need to answer the quantity the question is actually asking for. All right. So let's actually first concept that you should actually have. Okay, so with that being said, I want to go through a few simple. Oh no, not yet. We need to actually talk about the order first, so we can actually go through there. Okay. So that's pretty much the first type of question you're going to encounter. Okay. The second type question you're going to encounter is actually the red law. Okay, so you're going to see these things a lot. This will be actually the main focus of this chapter, the red law. In this specific chapter, there are actually two types of red laws. One is so-called the differential red laws. The second one is actually the integrated red law. Okay, so this is actually the first one. That is actually the second one. For the differential red law, you are going to always see something like this. It's going to have this form. Okay, the first you care about is actually the reaction rate. Okay, it's going to be equals to the product of your K. So this is lowercase italic K. Okay, make sure you see this is actually lowercase italic. Okay, lowercase italic. Okay, this is so-called the rate constant. Okay, lowercase k. Multiply A and B. Okay, not A, B, C, D. Just A and B. So what is A and B? Reactant. Okay, make sure you know when you write out a differential rate law, the rate can be expressed as a function of a rate constant K. Multiply the concentration of your reactant. Only reactant, not product. Okay, it cannot have productant in it. Okay, multiply the reactant terms, raised to certain power. Here you have this lowercase n and n, right? Let coefficients. It is not your stoichiometry coefficient. It is not a lowercase a. It is not lowercase b. Okay, those little small case n and n can only be determined experimentally. Okay, and then in many of your problems you're going to encounter for this chapter is actually asking to determine what is the lowercase n or lowercase n. Okay, and we're going to do a lot of practice on this today. Okay, so this is actually the first thing to know about the differential rate law. Okay, the reaction rate is going to equals to a rate constant K multiply the reactant concentration raised to some unknown power. Okay. Here, we are going to say the reaction rate is proportional to the reactant A raised to nth order. Is proportional to reactant B raised to the nth order. The overall reaction order, okay, so it's actually reaction order is simply the sum of the coefficients. Okay. For example, this specific equation, okay, you can say the reaction is proportional to the reactant A to the first order, right? And because this is actually the equation, this is actually differential rate law, you're right? Therefore, you can say the overall reaction order is just simply equals to 1. Okay. In the second example, I wrote here, the overall reaction order will equals to 2, right? It is first order for your reactant A, first order to your reaction B, reactant B, but the overall reaction order should be 1 plus 1 equals to 2. Okay, one more. So I write out this rate equals to K3 multiply A to the second power, B to the first power, right? So you're going to say it is second order to the reaction A, first order to the reaction B. Overall reaction has a reaction order of 3. Okay, so the overall reaction order is simply the sum of those exponents of each individual component. All right? Okay, with that being said, another very important thing, and you are going to get asked from your homework is like the unit of K. Okay, let's say you have a first order reaction. What is the unit of your rate constant? That's something that you need to know. Okay, let's do it one by one. Okay. The first one is actually zeroth order. Okay, how do we write out a rate equation that's actually zeroth order? You have something like that, right?
Yeah.
So it's actually, you can consider this. Okay, let's say this actually a reactant. You raise to the zeroth order, right? Whatever concentration raised to the zeroth order, the whole term become just 1, right? So if it's 1, I mean, it's basically like that, right? Okay. So in this case, for this zeroth order rate law, what's the unit of K? Apparently, your K is going to have the same unit of your reaction rate, right? What is the unit of your reaction rate? Molarity per second. Okay? Molarity per second is actually the final unit of your rate. Okay, so you can see that in the zeroth order, your rate constant is going to have the same unit as your reaction rate, right? Which is actually molarity per second. Okay, that's why we put here, right? So of course, this is actually the same as this, okay? How about the first order? We know if it's actually first order, this will be the equation that you're going to use, right? Rate is equal to your rate constant K multiply the concentration of A raised to the first power. Okay. You know your rate still is going to have the same unit, right? Molarity per second. You don't know your rate constant, the unit of your rate constant K, but you do know the unit of your concentration is molarity, right? So in this case, you know this and that will cancel out. Therefore, the unit of your rate constant K is just per second. Everybody follow this? Everybody understand? Okay. How about second order? It's basically this, right? So A to the second power. And you know the concentration now is actually become square. Okay, so once you cancel it out, you still have an M here, right? Therefore, your K will be 1 per second per M. That is actually a unit you're going to get. Everybody follow these things? I need some response. You guys like did not give me any response at all. What is the part that you don't understand? What you say? Where you actually get lost? Yes, go ahead. Yes. Okay, you need to know how to actually get the unit of the rate constant. Okay, and vice versa. If they don't tell you the order of your reaction, but they give you a rate constant, okay, they say, okay, the rate constant has a unit of 1 per second. You need to actually know the one has 1 per second. It's actually a first order reaction. A and B. I mean, if your second order is this, that the rate is equal to K times your A times B. Right? So what is the unit of this? It's still the same, right? Because you know your rate always has the unit of molarity per second. K is actually the unit you are going to find, right? For your concentration term, for your A is also just molarity, right? For your B, you also have molarity, right? And then you can cancel one of them, right? To make both sides equal to each other, then you know your K, the unit of your K must be per second. Per M, right? So that on the right-hand side, this term will cancel out with this, and you still have that. That will equals to the unit on the left. Make sense? How many of you still don't get it yet? I mean, like I say, you want to figure out these things in the class. If you don't know, that is okay, but you need to figure it out. Okay, so the key here is what? The unit of your rate is always molarity per second. Yeah. Yes. Yeah, good question. Okay, so how is this actually different from the integrated rate law? For the integrated rate law, okay, one keyword, time. In the differential rate law, you don't see time, right? Okay, so that is also a keyword you need to actually looking for. If you need to use the integrated rate law, it will ask you how long it take. Okay, time will actually play a big role. That is the keyword you're looking for the integrated rate law. Okay, but here we're actually talking about the unit of your rate constant, because the unit of your rate constant will tell you what is the reaction order. Okay, knowing the reaction order is actually essential for this chapter. Okay, so you know, okay, if I see this unit, do I know what is actually reaction order? Okay, or if I know this reaction order, do I know the unit of my K? Okay, you need to be able to switch between these two concepts. That is actually very important. Is that clear? Okay, so to recap, if you have a zeroth order reaction, the unit of K is molarity per second. First order per second. Second order per second per molarity. Third order per second per concentrate per molarity to the second power. Okay. So it is not difficult. Okay, all you need to know is actually how to write these things out and then how they actually corresponding to different orders. Okay. So let's say pretty much all the things that you need to know for the differential rate law. Okay. Integrated rate law. Okay. For the integrated rate law, what you want to know is that how the concentration of your reactant or of your product, how it actually change as a function of time. So in the integrated rate law, you're going to see this term, this equation is going to have this T going to show up. Okay. This table, okay, is actually all the integrated rate law you need to know for this chapter. It looks actually a lot of stuff, right? I'm going to show you what are the things that you need to actually memorize. The first thing you need to know is actually, this is a CHEM class. Okay, so the integrated rate law will only show up for the simplest case. When I say simplest case, is actually a single reactant reaction. A single reactant reaction, in this case, just A, right? AA becomes something else. Okay. For this specific condition, you need to actually memorize the integrated rate law for zeroth order, first order, second order. And that's it. 3 equations. Zeroth order, first order, second order. The equation to actually memorize is this. So these are the 3 integrated rate laws you need to actually memorize. Okay. Let's look at the zeroth order first. So the rate equals to K. That's actually the differential rate law we just talked about, right? Rate equals to rate constant K. Multiply your concentration A to the 0th power. A to the 0th power equals to 1. Therefore, you got this rate equals to K. Okay, so this is actually a differential rate law. This is actually a corresponding integrated rate law. A at time t is going to equal to negative K multiply t plus your A0. Okay. Where the K is what? The rate constant, right? T is what? Time. Okay, this is actually a part that students going to get confused. What do you mean by time? Okay, so if you look at this equation, it starts from AA, right? That means at time 0, you are going to have certain concentration of your A, right? That's actually time 0, right? And then you let the reaction to happen. That means actually time will start to tick, right? Time is actually passing, right? After a certain time t, you want to know the concentration of your reactant. Okay, so we call it as A at time t. Okay, that's what AT means. The concentration of A after the reaction starts for time t. Okay, it's going to equal to negative K, which is actually the rate constant, multiply the time that has passed. Okay, plus A0. What is A0? Yeah, very important. Initial molarity of your reactant A. Okay, all these things is actually very important. You need to actually recognize what is what. Okay, so like when you read the questions, it's very easy for you to actually assign the value to each individual variables. Okay. So knowing this is great. Okay, but let's actually another things you want to be very careful. Okay. If you look at this equation, if you consider this is y, it's minus k times your t plus something else, or plus a constant c. Okay. If you learn, you guys learned this before, right? So this is linear equations, right? So all it means is that if you plot out your concentration of A as a function of time, what do we expect to get? A linear relationship, right? So it will look something like this. Okay. The slope of this plot is what? Negative K, right? So the slope will give you negative k. Okay. What is this intercept? Yes, that's actually your initial concentration of your A, right? So this concept is actually very important. Okay, because one thing you probably will encounter in your homework or quiz is that it just gives you a bunch of concentration of your A at different time t. And it's going to asking you what is the actual reaction order. Okay, so if you plot out this concentration of A versus T, then you put out all those dots and they look like linear. That immediately tells you this is a zeroth order reaction. Okay, so you're going to see more and more important information here. Okay, but let's actually pretty much the things you need to know for the zeroth order. Okay, we're going to repeat the same thing for the first order. Okay, so the first rule, rate equals to rate constant k multiplied to a to the first power, right? So let's actually the differential rate law of first order, right? The corresponding integrated rate law is this. Natural log a, again, at time t is going to equal to negative k times t plus natural log a0. Okay. Similarly, if you draw out this natural log at versus t, you also get a straight line, right? The slope, again, is going to give you negative k. The intercept will give you what? Natural log a naught. Okay. One thing that first order differ from the zeroth order is that right now you're plotting your y in different units, right? For the zeroth order, what do you plot out? At, right? If you plot out your at versus time, you get a straight line, zeroth order. Okay. For the first order, if you just do the a versus t, you apply it out, it is not going to give you a linear behavior. Okay, it's going to give you an exponential. Okay, but if you plot out natural log at versus time, again, you go back to this linear relationship. Okay, so from the shape, okay, depending on the y quantity you plot out versus time, okay, it can actually inform you what is the reaction order that you're going to have. Okay. Very last one, second order. The different rate law equals rate of K times A concentration raised to the second power, right? These things actually, you need to actually plot what? 1 over A as a function of time, where the slope will give you K. The intercept will give you 1 over A0. Okay, so you need to be able to recognize. In order to know what reaction order that you have, okay, you probably need to actually try to plot these things in 3 different versions. One is you plot out A versus T. The second is you plot out natural log A versus T. The third one is actually 1 over A versus T. Okay, see which one gives you the linear behavior. And that one will be actually give you the reaction order of your reaction. All right. Okay, any questions so far? So far, so good. There's a lot of concept we went through, okay? Everybody's fine? Okay, everybody's fine. We're going to do some practice now. All right. Okay, so let's look at the first questions. Okay, so this one is actually the simplest one, right? What is the reaction order for Br minus for reaction with the following red law, where the red is equal to rate constant K times your BrO3 minus Br minus and H plus to the second power. So what is the key word? Very good. So right now everybody can see this thing's reaction order, right? So every time you see this reaction order, it probably is actually related to your differential rate law, right? Therefore, you want to actually know the order of individual reactant and also the overall reaction order, right? So here, specifically, you want to actually know the reaction order of Br minus, right? So if you look at your rate law, the differential rate law, give you rate equals rate constant K multiply BrO3 minus to the first power, Br minus to the first power, and then H plus to the second power, right? Since it is actually only talking about the order of your Br minus, right? Therefore, this is actually the answer you should actually input. That's first order. Okay. To make these things more complete, right? So if it's asking you the reaction order of your BrO3 minus, then it is also first order, right? If asking about the H plus, then it will be second order, right? How about reaction order? It will simply equals to the sum of all this, which is going to give you a value of 4. Okay, so this example is actually testing you. Do you know the difference between the reaction order and the order of individual reactant? Make sense? Everybody know how to solve this? Okay. So let's actually the first questions. Okay. The second question. Consider reaction with this red law. By what factors does the rate change if the concentration of H plus is quadrupled? Okay. Again, this is actually apparently a differential rate law questions, right? Where the rate is going to equals rate constant K BrO3 minus multiply Br minus multiply H plus to the second power. Okay. So what it asks you is that if I quadruple my H plus concentration, I will actually change my reaction rate, right? So what does this mean? This means the H plus concentration now become 4 times, right? Okay, so the new rate is going to equal to the same rate constant K BrO3 minus first power Br minus first power. Now it's actually 4 times your H plus square, right? So this is actually your new rate. Okay, I want to actually differentiate from the original rate. Okay, so by doing this, this will equal to 16 times your K times your BrO3 minus times your Br minus times your H plus to the second power, right? And then you still see that this whole term is actually this whole term, right? Therefore, the new rate will equals to 16 times of your original rate. Everybody follow this? Make sure you actually follow this, yes. Yes, so this is actually the only thing that's new, right? And then you need to actually consider the effect of those exponents, right? So, mhm.
The other one. Just add that. So there's two BR negatives,
Mhm.
and to the second order. So you just do 4 times 16 times K. That'd be another vacuum effect.
Okay, so let's do more practice. Okay, here is simple, right? Here you only change one component, right? What if I say I quadruple my H plus and I double? Okay, to make it more clear, it's actually I triple my BR minus. Okay, so assuming there's actually a new question that we are going to have. Okay, so when you write out your new rate, it's going to equals to the rate constant K is not going to change. Okay, your reaction is actually the same. Okay. You did not change the concentration of your Br3 minus, right? So just write out the same concentration over there. For your Br minus, now it's actually triple, right? That's what it means. Okay. And then if you also quadruple of your H plus, that's what it means, right? So once you have this, you can put all the coefficients to the very beginning. Okay. So these three, this is actually 16, right? So that's actually 48, right? Okay, I'm going too fast. Okay, it's 3 multiplied 16, right? Times your K times your BrO3 minus times your Br minus times your H plus to the second power. Okay, so you know this gives you 48. This is actually the definition of your original rate, right? Therefore, you know your new rate will be 48 times faster compared to the old one. Okay, so that is actually how you estimate. Okay, when you change the concentration of your reactant, how will that actually affect your reaction rate? I hope this is actually clear. Yes. How do I get 16? So see the seconds power, right? You need to actually multiply inside. Okay, so you have H plus square here. You also have the 4 square, right? And I move that 4 square to the front. Does that answer your question? Okay, good. Any other questions? Okay, so this is actually a simple calculation. Okay, you want to actually make sure you can get the things right. Right? Cool. Let's look at third questions. Okay, this is actually things that are going to become very interesting. Okay, so let's give you actually a bunch of data that is actually a unique feature of this differential rate law. Okay, so every time you see a table like this, 99.99% is actually testing you can actually write out the differential rate law for this reaction. Okay, so I guess the keyword is actually the table. Okay, the table is actually a keyword that asks you to do this differential rate law derivation. Okay. All right, so this, okay, if I'm going to read through a question really quickly, okay, it says, given the data below for the reaction, okay, for this specific reaction, the reaction is X1 order in A, X2 order in B, X3 order in C, and X4 order overall. Okay, they want to know those numbers. Okay, so how do you actually start with this? Okay, when you write out, apparently I say the keyword is the table, right? So once you see the table, you know it's not going to test you, it's going to ask you to write out the differential rate law. Okay, so what is the key element of your differential rate law? It must have the form like the rate is going to equal to your rate constant K multiply your reactant to a certain power, right? What are the reactant for this reaction? A, B, C, right? So you know it must be A times B times C raised to a certain power, right? And from the description, you know it is X1 order in A, right? x2 order in B, x3 order in C. So you can actually naturally write out these things from the description. Okay, and that is actually the first step to solve this problem. Okay, any problem, any problems for this step? Okay, make sure you can write this. Any question? Okay, make sure you can write it down first. Okay, and let it actually get started. All right. So once you know this, what you're going to do is that if you look at these 4 specific reactions, right? You know the initial rate is what? 2 times 10 to the negative third, right? So this is actually your rate, right? It's going to equals to your A is what? 0.1 to the x1 power, right? B is 0.2 to the x2 power times 0.4 to the x3 power. Okay, I want everybody be able to write this equation now. Okay, make sure you can actually write these things out. Okay. So once you have done this, okay, what you're going to do next is actually you're going to repeat the same process for row 2, row 3, and row 4. Okay, so for the row 2, you know is 2 times 10 to the negative 3 is going to equals to 0.2 to the x1 power, 0.2 to the x2 power, and 0.4 to the x3 power. Okay, and then for the next one will be 4 times 10 to the negative 3 is going to equals to 0.3 to the x1 power times 0.4 to the x2 power times 0.4 to the x3 power. And the very last one is 1.5 times 10 to the negative 3 is going to equals to 0.4 to the x1 power, 0.6 to the x2 power, 0.2 to the x3 power. Okay. So far, so good. Everybody can write this. Okay, you need to write this so you can actually go to the next step. Okay. So once you write out this 4 equation, the only thing you want to actually solve is actually solve the x1, x2, and x3 accordingly. Okay. In this type of reactions, you will always be able to find out 2 equations where your x2 and x3 are actually the same. If you look at the first 2 rows, okay, if you look at the first 2 rows, you'll realize that the concentration of your B is the same, right? Concentration of your C is the same, right? The only thing that different is what? A, right? So what do? It's actually your equation number 1, 2, 3, and 4. So what we're going to do is that if I do, okay, so if I do equation 2 divided by equation 1, okay? So on the left-hand side, what do you get? 2 times 10 to the negative 3 divided by 2 times 10 to the negative 3 is just 1, right? Very simple, right? On the right-hand side, 0.2 to the x1 power divided by 0.1 to the x1 power. What will it be? It will be 2 to the x1 power, right? So I use the second equation divided by the first one. Okay, so on the left-hand side is going, they are the same, so you get 1. Okay, then I focus on this term, right? 0.2 to the x1 power divided by 0.1 to the x1 power. Okay, so if the exponent is the same, you can just write 0.2 divided by 0.1 raised to the x1 power. In this case, it will just give you 2 to the x1 power. Okay, everybody follow this? Okay, so you know, I'm going to erase this. Okay, by doing so, then you know the first term will become 2 to the x1 power on the right-hand side, right? Second term, what do we get? That's 1, right? 0.2 to the x2 power divided by 0.2 to the x2 power. It's the same thing, right? So it's just equals to 1. How about the third term? It's also 1, right? Because it is 0.4 to the x3 power divided by 0.4 to the x3 power. Right? So from here, you can actually know you're actually trying to solve your x1, right? The 2 to the x1 power is going to equals to 1. Therefore, your x1 will equals to 0. Okay? So let's actually, now you actually got the value for your x1, right? Now we want to just solve for your x2, right? If you want to solve for x2, you want to cancel out your x1 and x3, right? So the things you want to actually, the two equations you want to do is actually the concentration of your A and the concentration of your C will be the same. Okay, so do you actually find anything like that? In this case, do you have that? A and C are the same. You don't, right? Yeah, so what do you do? Under this case, most likely the x1 will be used. Okay, what is the value of your x1? 0, right? So whatever concentration of your A doesn't really matter because that concentration to the 0 power is going to give you just 1, right? So to solve your x2, all you find is actually you want your C, they are the same, right? So that is actually logical thinking, all right? So what you can do is actually, okay, let's say I want to do these two, okay? So if I do my equation 3 over my equation 1, what do I get? On the left-hand side is 4 times 10 to the 3 divided by 2 times 10 to the 3, right? So you know on the left-hand side, all you get is 2, right? Okay, then for your A is 0.3 divided by 0.1. That's actually 3, right? But since the x1 is 0's power, so let them become just 1, right? Everybody follow this? Everybody follow? Okay, good. Okay, and then the second term, 0.4 divided by 0.2, that's actually 2, right? To the x2 power. That's the things that you want to find out, right? The third term, 0.4 to the x3 divided by 0.4 to the x3, it is 1. Okay. So to summarize this, it is 2 to the x2 power equals to 2. Therefore, your x2 is going to equals to 1. All right? Yes. Which one? You mean this one? This one? Okay, so we are doing 3 over 1, right? So when you do that, what you get is what? 0.3 over 0.1 raised to the x1 power. And this term is 3 to the x1 power, right? And we know x1 is equals to 0. Therefore, this is going to give you a value of 1. Okay, I hope, yeah, it's good though. If you don't understand anything, just ask, okay? All right, so up to this point, you actually figure out your x1, x2, right? So you're going to use similar approach to figure out your x3. Right? So what would you pick? You can actually pick anyone. Okay, because right now your x1 is known, x2 is known, right? So you will use those two numbers as well. So you can pick anyone. Okay. So I'm going to pick, let's say I want to do this. Okay. So if I do equation 1 over equation 4, so what do I get? On the left hand side, it's 1 over 4, right? So I got 2 over 1.5. Everybody follow this? Okay. And then 1 over 4 to the 0th power. Okay. And then 2 over 6 to the first power. And then 4 over 2 to the x3's power. Does everybody follow this? Yeah, I hope you can see why I write all these things down. If you don't, let me know. I can, yes? A little bit louder. So why 2 over 1.5? I use 1 divided by 4, right? So it is 2 times 10 to the negative third over 1.5 times 10 to the negative third. Right? And then this can be canceled out. Huh? Okay, so yeah, so I divide this by this, this by this, this by this. Okay, so make sure you understand how I do it. Okay, because when you do your homework, you are the one to actually repeat this process. Okay, yes. You can pick any two. Yeah, it doesn't really matter. Okay, because it will actually all cancels out in the end. Okay, so let me make these things a little bit cleaner. Okay, so once you have this, apparently you can see that this is 2, this is actually 1.5. The first term is simply equals to 1, right? The second term is actually just this, right? And then multiply 2 to the x3's power. Okay? So these things, okay, so this can be further written as this. Right? So this one can be actually written as this. Right? I multiply 2 on the numerator and denominator. Okay, so this one is equal to this. Right? This is actually the things that you have on the right. Okay, so this will cancel out, right? Therefore, 2 to the x3's power equals to 4, right? Therefore, your x3 is going to equal to 2. All right? Yeah, so that's actually how you figure out the very last one. Okay. Any questions so far? Yeah, how do I get this 4 over 3? So why do I do this, right? So this is actually the things that I guess everybody follow this, right? So you know on the right, what you have is actually 2 to the x3's power divided by 3, right? And this whole term is going to equal to 2 divided by 1.5. Okay, so to cancel out these 3, I mean, the easiest way is actually you multiply 2 on this side, right? On both your numerator and denominator. Okay, so if you do that, then you got this, so that you can actually cancel out the denominator on both sides. Okay, so that you can easily see that x3 has to be equals to 2. All right. Yeah, of course you can pick any other two equations because right now you already know your x1 and x2. Okay, yes. You could, it will just split over. Yeah, and your 2 become 1/2, right? And sometimes I found it's actually more difficult if it's actually 1/2 to the certain power to figure out the exponent. If it's actually 1/2 is sometimes not so easy to get the answer quickly, right? You always want to have like 2 to the certain power because that's actually the one we are most familiar with. Okay, so when you choose the two equations, right, make sure that once you actually do the divisions, that number is actually some number you're actually familiar with. Typically, it's like 2, 3, or 4. That's actually a typical number you're going to encounter. All right. I hope everybody follow this along because you're going to see this question over and over again. Okay. So now you know what? You know your x1 is 0, x2 is 1, x3 is 2, right? Therefore, you know your rate is going to equal to your k times a to the 0th power, b to the 1st power, c to the 2nd power, right? And then the overall reaction rate is 3, right? Because 0 plus 1 plus 2 equals to 3. Okay. Any questions for this? You practice, go back home and practice this a lot. Okay. Then actually really make sure you know how to what is the logical thinking. It's very important. Okay. Any question for this? Okay, so if not, even though I did not write here, okay, another question I'm going to encounter is that what's the k? What is the value of k? How do you get that? Oh, yes. This one? You mean this part? So I multiply 2 on top and bottom. I did not actually get where you are talking about, but is this actually area you want me to explain more or? So I guess you don't have problem up to this point?
Yeah.
Okay, so what I do next is actually I erase all the things. This whole term becomes this, right? Of course, 2 to the x3 power divided by 3. That's actually things that you have on the right-hand side, right? And then it is going to equal to 2 over 1.5 on the left-hand side, right? And then I want to actually remove my denominator. Okay, so one way is actually you multiply 2 on the top and the bottom at the same time. That's actually one way to do it. Okay, the other way to do it is that you just multiply by 3 on both sides. Okay, so if you do that, this will cancel out, right? This will give you 2, therefore this will give you 4. Okay, and then going to give you 2 to the x3 power. Therefore, you can figure out x3 is going to equal to 2. Will it be actually more straightforward? I guess. All right. Okay, so any other questions for this? Okay, so if not, the next important things related to this question is actually, can you get the value of k? Okay, it's actually relatively easy, right? Because right now you know the reaction order, right? So what you do is actually you pick one of the conditions that you have. You know your rate, which is 2 times 10 to the negative 3, right? K, the value of K is something you want to actually solve for. Concentration of your A is 0.1 to the 0th power is simply equal to 1, right? Concentration of B is 0.2 to the first power. Concentration of C is 0.4 to the second power, right? So having this equation allow you to actually back calculate what the K value is for this specific reaction. Okay? So to summarize this type of reaction or this type of question is that from the experimental data, okay, by compare two row of data, you should be able to figure out the order of each individual reactant and also the order of the overall reaction. Okay, once you figure it out, then we use the data that you have here. You should be able to calculate the value of your rate constant K. Okay, so those are pretty much all the things that you're going to be at for this type of question. All right. Any questions for this? Okay, so yeah, yes, you can actually do the estimation for each row. Okay, they'll always give you a, if not the same, it will be very, very close to each other because you can consider when you do experiment, there will be some errors. Okay, but the K value should be actually very close to each other. Okay, so that is the question you're going to encounter for your question number 3. Okay, so let's finish question number 4 and we'll call it a day. The reaction AB become A plus B has a rate law of rate equal to AB to the second power. Calculate the rate constant. If it takes 120 seconds to reach AB of 0.2 m from the initial concentration of 0.8 m. Okay, so what is the keyword here? No, not the rate constant. I got the answer actually. When you see seconds, what does it mean? Integrated rate law, right? See, this is why it's so important to know what the keywords that you want to actually remember, right? Seconds, integrated rate law. Okay, what is the reaction order? Seconds order, right? So what is the equation to use? Seconds order, not first order. See, it's less simple. You know it's second order, you know exactly integrated rate law. That is the equation to use. Cool. All right. Now it's the time for you to actually reread the question. Reread the question. I can figure out what other information have been provided. Okay, so let's read this. You want to know the rate constant. You want to know this, right? The K. That is actually a term that you want to solve. If it takes 120 seconds, what does that mean? That is the time, right? So your T is 120, right? And then it says to reach a AB concentration of 0.2 m per 0.2 m, right? Mole per liter is actually molarity, right? So what is this value correspond to? 0.2 is what? Your A or A not? A, right? So you know this is 1 over 0.2, right? 0.2 equals to K times 120 plus initial concentration is actually 0.8, right? Can you solve this equation? Can you get your K? It's simple, right? Yeah, so why this is simple is because we can recognize the keyword is second time. And then from the differential rate law is actually seconds order. Then you can write out the equation immediately, right? And then you reread your questions to input the information that have been provided. Then you can actually solve the unknowns, and they will be actually the one you are looking for. Okay. Before we leave this, okay, let's actually one more trick they can play for this type of question. Okay. So here it says it takes 120 seconds to reach this concentration. Okay. That's actually one way to describe your concentration of your AT. The other way they can actually describe is that they're going to say they have consumed okay, if they say they have consumed 0.6 molarity of your AB, okay, when they start from 0.8 mole, okay, if they say consume 0.6, that means what? You still have 0.2 remains. Okay, so this is actually the one that remains, not the one that got consumed. Do you see the differences? It is very important that you see this. Okay, because that is actually a place they're going to play tricks on you. Okay, so hopefully this will actually give you a good sense about how to solve questions like this. Okay, so I will stop here for today's lecture. What do you mean? Come.